Hello and welcome to the third lecture of our course. In this lecture, we are diving into the often overlooked world of energy bills. Specifically, we are going to discuss why understanding your energy rate structures is so crucial for effective energy management. As we discussed before, energy costs are a significant operating expense for most businesses and organizations. Yet, many managers treat these costs as uncontrollable overhead expense. This is where a deeper understanding of rate structures comes into play. Knowing your specific electric rate schedule and the costs associated with demand, consumption, and power factor is essential for controlling and reducing expenses, especially since the trend of energy costs is upward, particularly for electricity, making this understanding even more crucial. Let's break down why this knowledge is so vital. First and foremost, cost control. Energy expenses often form a significant portion of production costs. If these costs are treated as overhead, they can be difficult to control. Understanding your rate structures allows for better accounting of these costs. By understanding the various components of your bills, you can identify opportunities to reduce consumption, shift usage to off-peak times, and ultimately lower your bills. Next, informed decision making. A solid grasp of rate structures lets you determine the operating costs of individual pieces of equipment. This is vital when evaluating potential savings from energy management opportunities, such as high-efficiency lighting or motors. So, understanding costs of demand charges, energy charges, and fuel adjustment is vital for making well-informed decisions. And then identifying saving opportunities. Analyzing bills while understanding rate structures can uncover hidden areas of energy waste. For example, you may see discrepancies in energy usage that indicate where to focus your efforts. By examining your bills, you can calculate average, peak, and off-peak costs, revealing patterns and potential savings. Fourth, there is a utility negotiations. Managers who are well versed in their rate schedules can actively participate in utility rate hearings and collaborate with utilities and rate commissions to establish fair rate setting policies. Furthermore, they can investigate options such as receiving service at a higher voltage level or even installing their own transformers to potentially reduce costs. Now, let's consider understanding utility costs. By understanding how utility costs related to infrastructure, debt interests, and profits are allocated to different customers, you can help them minimize costs. Avoiding penalties. Large energy consumers can avoid penalties by understanding power factor charge and implementing corrective measures. Taking advantage of incentives. Some utilities offer rebates or incentives for implementing energy efficient measures and load management programs, and an understanding of the utility rate structure will help to identify such incentives. Planning for curtailments. Knowing your rate structures and priority levels will be also useful for preparing for potential energy curtailments and minimizing their impact. Finally, analyzing energy bills. Energy bills must be broken down into their components to determine costs for individual pieces of equipment. This is necessary to calculate savings from energy management opportunities, such as using high efficiency lights, high efficiency motors, and shifting operations to off-peak times. For example, let's assume you have a small industrial facility on an industrial rate schedule. The facility consumes 300,000 kilowatt hour of energy per month with a peak demand of 100,000 kilowatt. If your facility is located near a transmission line, you could potentially purchase your own transformers and accept electricity service at a higher voltage level. By doing so, you might reduce your demand charges, as losses in transformation would now occur on your side rather than being part of the utility's demand calculation. Additionally, energy charges may decrease if the utility provides discounted rates for service at higher voltage levels due to reduced losses and infrastructure costs. Let's explain the key concepts in this example. Number one, the energy consumption. Energy charges are based on total energy used during the billing cycle. This is the 300,000 kilowatt hour in this example. Second, demand. Demand charges are calculated based on the highest level of electricity demand over a specific time intervals during the billing cycle. This is the 1000 kilowatt in this example. Accepting power at a higher voltage can reduce the recorded demand since transformation losses from lower voltage systems are avoided. Third, service voltage level. Utility companies often offer lower rates for customers who can take service at a higher voltage level. Example, from a transmission line instead of a distribution line. This reduces the utility's infrastructure burden and losses. Fourth, transformer and costs. By purchasing your own transformers, you take on the cost and responsibility of maintaining this equipment. However, this can lead to long-term savings through lower demand and energy charges, provided the reduced utility rates outweigh the capital and maintenance costs of the transformers. And finally, the visibility. The financial benefits depend on utility tariff structures and whether they offer significant discounts for high voltage service, the cost of acquiring, installing, and maintaining transformers, the proximity to the transmission line, and associated connection costs. In conclusion, understanding energy rate structures is a basic requirement for successful energy management. It enables well-informed decision-making, allows you to control costs, and reveals opportunities for savings. This is in turn improves your organization's profitability and competitive advantage. Thank you. See you in the next lecture. And don't forget to check the previous videos of this series and subscribe to our channel for more videos on energy, sustainability, and decarbonization.